All right, this is Pythagorean theorem. It is section 5.8 on page 437 in your pre-algebra text. And it discusses how at the beginning of this, how the Pythagorean theorem came about. It's a pretty cool theorem, and there's lots of videos and information out there on how it came about. We're just going to talk about it and learn about it mathematically and utilize it. It has to do with a right triangle, so I'm going to draw a right triangle on my board to represent a similar one in the book. A right triangle means that one of the angles is a right angle, and a right angle is a 90-degree angle. So this works for right triangles. When you have a right triangle with a 90-degree angle, the two sides that come together at that vertex point to make the 90 degrees, those are called legs. And then the side opposite the 90-degree angle is called the hypotenuse. Hypotenuse. And in the Pythagorean theorem, one of the legs is an A leg, and one of the legs is a B leg, and the hypotenuse is the C side. And that's important to kind of remember when we talk about what the theorem looks like. So on page 438, it draws the drawing again, just showing the A, the B, and the C for the legs rather than saying legs and hypotenuse. So we have an A, a B, and a C. So the legs are A, B, and the hypotenuse is C. And the Pythagorean theorem then is the formula A squared plus B squared equals C squared. What it's saying is leg squared plus the other leg squared equals the hypotenuse squared. So this theorem allows you to solve for any one of the sides if you know the other two sides. You can apply basic algebraic skills using additive inverse and using our square root to undo squaring, and we can solve for any measurement of any side of a right triangle. So we're going to try it in example 1. They say that you have the legs of a right triangle are 3 and 4, and you need to find the hypotenuse. We don't know what the hypotenuse is. So knowing this formula A squared plus B squared equals C squared, the Pythagorean theorem, we know we can substitute in our information for each one of these variables and solve for the unknown variable. So our A leg is a 3, so we substitute in 3 for A, 3 squared, plus our B leg is 4, so we have 4 squared, and that's going to equal C squared. So we go ahead and simplify this. 3 squared plus 4 squared, that would be 9 plus 16. That's going to equal C squared. We add the 9 and the 16 and we get 25 equals C squared. Now some students would stop there and say, oh, we're done. But we're not, because the C isn't really by itself. It has a little square next to it, doesn't it? So you just learned in the square root section about the opposite of squaring is square rooting. So to undo squaring, we're going to square root both sides of our equation. So if we square root C squared, we get C. And then if we go to the other side and do the exact same thing to keep our equation balanced, whatever you do to one side, you have to do the other, then the square root of 25 is 5. So our hypotenuse then is 5. And if we check our answer and we plug that back in, we would have 3 squared plus 4 squared equals 5 squared. Is that true? Well, 9 plus 16, does that equal 25? Yes, 9 plus 16 equals 25. So our hypotenuse is 5 units. Okay? So it walks you through that example on page 439. Then we're going to find, now we're going to have a triangle on page 440 where we're going to be given a hypotenuse of 13, a leg of 5, and we're missing a leg on a right triangle. We're missing the B leg. So we're going to substitute in all our values and solve, and we've got to do a little more algebra on this one. Okay? So we're going to have 5 squared plus x squared or b squared, whatever you'd like to say. We substitute in the x for the b value, equals 13 squared. So 5 squared is 25, plus our x squared equals 13 squared. That means 13 times 13. Okay, that's 169. Now notice we have 25 plus x squared equals 169. We want to get x by itself. 25 is over here hanging out next to x, a positive 25 adding itself, so we're going to subtract or do a negative 25 to both sides. We're going to use our additive inverse to get rid of that 25. We have x squared equals 144. Now we want to get x by itself, so we have to square root it. The square root of x squared would be x, and so we have to square root the other side of the equation, so the square root of 144 is 12. So our b side, our x value, is 12. If we checked our answer, 5 squared plus 12 squared, does that equal 13 squared? Well, 5 squared is 25. 12 squared is 144. If we add 25 and 144, sure enough, we get 13 squared, which is 169. So we did it right. Okay? So we're just applying that formula over and over and over again. Those are using perfect squares. Sometimes we don't have perfect squares, so you got to get your calculator out. The next example 3, has an upside down right triangle. It doesn't matter what position it's in. It's still a right triangle with that little right angle indicator. Looks like they're giving us the hypotenuse and a leg, so we're missing a leg. So we have x squared plus 7 squared equals 12 squared. So we're going to have x squared plus 49 equals 144. We notice that we've got plus 49 adding itself to x squared, so we're going to need to subtract the 49 from both sides. We end up with x squared equals 95. We square root both sides, and x equals the square root of 95. We don't know exactly what that is. If we wanted to say exact, we would just say exactly the square root of 95. Or we could approximate it on our calculator, and we could punch in the square root of 95 on our calculator. I just realized I didn't have a calculator, so I'm grabbing one. So except my calculator is dead. Gotta grab another one. Okay, so we would do so it's about 9.75. 9.75, right? So you could either answer it exactly as the square root of 95, or you say that it's approximately 9.75 units. And so that's where you get to start practicing with that calculator, okay? There are some story problems that involve right triangles. Just draw yourself a picture and solve the Pythagorean theorem. So that is section 5.8, Pythagorean theorem. A squared plus b squared equals c squared. So if you're finding c squared, you just have to add your a squareds and b squared and square root it. If you're finding either leg, a squared or b squared, you have to square your side, your hypotenuse and leg. Then you have to subtract the leg from the hypotenuse and then square root it. So you have to do one extra step. Okay? Does that make sense? I hope so. Practice that Pythagorean theorem. It's pretty fun. Just remember your ABCs. A squared plus b squared equals c squared. And that's the end of chapter 5. We'll see you in the next video.